Okay, this is Softtech's SpotChecker. Now, first thing I'm going to do is show you the major components of the system. So the first thing we have is the SpotChecker itself. And the SpotChecker has a measurement head, and it has a footprint which is 1/2 of an inch by 1.5 inches. And ultimately we're going to stick a sample underneath that region and take data. So that's basically what our objective is. Now, that's the SpotChecker. The next thing we have is an electrostatic pinner. So the reason we use that is when we put a piece of ceramic onto the carrier, we want to pin it to the carrier so that it's nice and flat. And then after you've done that, you can handle it without hurting the sample at all. This we call the frame. The frame carrier is what you put the sample on. Now the software is on the PC, and as you can see with the software, what we're going to be doing during the data acquisition, we step on the foot switch, which I have down here, which you can't see, and we're going to be taking data like that. Let me clear that. Yeah, clear plot. There we go. So that's the basics of what we're going to be doing there. Now down here, I guess I should refer to this. We're using an Ames micrometers, and you can see that's what we're going to be doing today. When we calibrate, we're going to be using the micrometers. There are other ways to calibrate where we could measure the average thickness of a sheet of ceramic and then weigh it to determine its average thickness, and then we could also calibrate with that. So for today we're going to be using these micrometers. Now down here at the end of the table we have your samples. So in this particular case, that's sample number 1 that we have sitting on that black grid. So that's where we're going to be taking our sample test. Okay, so here we're going to prepare a sample for you. So what AJ is going to do is we're going to take half of this sample okay, so he's cut that nicely. Now he's going to transfer that onto this frame, and he's going to be doing that so that it's on there in a particular way. He's going to leave enough room for me to tear the polyester. Yeah, and you can see it sliding around. Now the next step is to use the electrostatic pinner. So we're going to put the sample down. All right, turn on the pinner, and now we're going to smooth it out. That's trying to get any wrinkles or any kind of air bubbles out of the sample so that it's sitting perfectly flat on that frame. So that's being electrostatically pinned as he does that. You can see how nice that surface is of the ceramic material. This was designed specifically for this measurement system. Okay, you happy with it, AJ? Yeah, okay, now the next step is to turn off the electrostatic pinner and slide the system off. It's pinned pretty well. Okay, and that constitutes our sample preparation. Okay, so now we're going to find out how thick the ceramic is. So we're coming in on the polyester, which is roughly 1 mil thick, and we're going to zero on that. So we zero on that, and now that's reading 0, and then we move on to the material. And I'll let it down. So that's 150, 145, 145, 145, and 145. So we're going to count that as a 145. Okay, now we're going to calibrate the SpotChecker based on the information that we got from the micrometers. So the first thing I'm going to do is I'm going to move in on the polyester, and right now it's reading 1.22, which is fine, and I'm going to set the tare and capture it so that the polyester is reading 0. The next step is to move in onto the material right where I had the micrometers. Now when I did the micrometer test, we had that, we know that was 1.45 mils. So I go to setup and I type in the results I got from the micrometers, which was 1.45 mils, and we set it. And now, if you notice, the screen is reading 1.45. Now I'm going to put this in the recipe table. So you'll notice there's two tabs up here, one's setup and the other one's recipes. And so what I'm going to do is create a new recipe, and we'll call it sample 1. And I'll say OK, and now it's going to capture that recipe. So now we have a recipe in the table for that material. So I'm going to apply it and close it, and you'll see that now the instrument says we're calibrated for sample 1. Okay, now what we're going to do is take data on the ceramic material, and so AJ is going to translate the material through and take data on it. He's going to go every ½ inch. So we get a ½ inch profile across the material. You can see this material has a thick spot in it. Okay, and you can get one more out of it. Yep. Okay, so there's our 12 data points across that sample, which is enough. And what we want to do next, you can see the statistics. The average was 1.42. It had a range of 0.09 mils. It did have a visible thick spot. These areas here are actually visible when you look at the sample. So what I'm going to do next is I'm going to export this data. Are you ready?
And go.
Now we want to export our data to Excel. So we have our data points, our 12 data points here. And so I'm going to say export to Excel. Do you want to export? Yes. And so now Excel came up, and you can see that it automatically exported the data that was on this screen. It was here. And it tells the date that it was done, the time that it was done. The statistics are here: average, max, min, range, and standard deviation. And then there is a replication of what the data was, showing the different data points on the data. Now you can save that, and now you have a permanent record of that particular sample and how it measured. Okay, so in this particular section of the video, what we want to do is show the reproducibility. So in this particular case, we didn't take any great pains to do this, but this was run 1, and we went through. This thing goes to sleep on me. And we were going to open for view the second sample we took, which is this. You can see it's a little bit different. And then File, Open for Overlay, sample 1. And open that, and that we can overlay. Now we didn't take very many great pains to get this just right, so we kind of did it so that it was less than perfect, so you could see the difference between the two. But you'll notice that the range is still the same between the two, and the average is within 10 millionths.